Hey guys, and welcome back to class. So this is probably your second day doing math. Last time we talked about our product rule. That was the first exponent rule we talked about. Well, we will be talking about two exponent rules today. Okay, the two exponent rules that we will be talking about today are the quotient and the zero rule. Okay, you're gonna love this zero rule. Okay, awesome. So first, just like last time, we started by kind of defining what is product rule. Let's give an example of what it looks like. So let's do that for our quotient rule, okay? So quotient rule, here's the formula or the quote-unquote definition. Okay, we're gonna say we have x to the a, okay? I'll put in a number in a second, over x to the b. Okay, these are just placeholders for now. Okay, well the formula for our quotient rule means x to the a minus b. If you remember from last time, our product rule, we were adding a and b, right? They were being multiplied, so we were adding them. This time, with quotient rule, okay, quotient means it's being divided. That's what that fraction means. Okay, and now we are not adding them anymore. We are subtracting them. Okay, subtracting our exponents. Okay, beautiful. So whenever you think quotient rule or whenever you see quotient rule, you can think subtract them. Okay, well now I want to give kind of a little bit more of an example of this. Okay, so let's kind of draw this out. Let's do it just like we did last time. Let's expand our exponents and give another example. Okay, so we're going to expand it over here. So let's say we have x to the fourth over x squared. So we'll say that our a became 4, and then our b became 2. We just made those so that they're numbers, right? They're actual exponents. So let's expand it. Remember what expanding it means? Okay, if you want to pause right here, what does expanding it mean? Do you remember from last time? Awesome. So expanding it means you're just taking this and it's almost like you're stretching it. Okay, so we're going to stretch it. So x to the fourth means x multiplied by itself how many times? 4 times. Beautiful. Okay, then we have over x squared. X squared, or x to the second power, means it's multiplying 2 times. Okay, this is where the quotient rule gets really cool. Okay, in math, whenever we have a fraction and we have the same thing on top and bottom, what happens is those two cancel out. What they're actually doing is it turns into a 1, turns into an invisible 1. But you can really just think they cancel out. So there's an x and an x right there, and another x and an x right there. Okay, so you can think of two things. Think subtract or cancel with our quotient rule, okay? Because they're subtracting, right? And I'll show you that in a second, but they're really just canceling, okay? So what is our answer now? We canceled them, but what does this actually mean? How many x's are left on top? X to the what power? 1, 2. Okay, we have x squared on top. What do we have on bottom? Nothing. We have nothing left on bottom, okay? Technically, we have an invisible, creepy number. Do you guys remember what the creepy number is in math? Okay, it's 1, right? But whenever we have a 1, so x squared over 1 on bottom, we don't have to write that. That just stays x squared. Okay, so that's how you would solve it if you were to expand it and cancel it. I really, really love this method. Okay, I'll probably put a star right there because I really love that method. Okay, but let's do another example where we're just subtracting it. Okay, let's say we have, same thing, x to the fourth over x squared. Okay, we'll just subtract them. So this is going to be subtract our top over our bottom. So 4 minus 2. What do we get? What is 4 minus 2? What is x going to be to the power of 2? You got it, x squared. Same thing, right? Check. So you can think of it both ways. Either subtract our top from our bottom, 4 minus 2, or expand and cancel. Okay, so that's our quotient rule. So let's do a couple examples. Okay, let's zoom in here and let's do number 2. Okay, so we're asked to simplify these expressions. Okay, so we have 4 squared over 4 cubed here. So I'm going to rewrite this. I'm going to expand it. So I'm going to use the same color. So I'm going to expand it. Okay, so I have on top 4 squared. That means 4 times itself twice. Okay, on bottom we have 4 cubed. That means 4 times itself 3 times. Okay, well now what we can do, we are going to cancel them out. If you see something that's the same on top and bottom, they can cancel. So I see a 4 and a 4 right there, and I see a 4 and a 4 right there. Okay, this one's different than our example because what is the creepy invisible number that's left on top? Right, it's that 1. Okay, 1 over 4. Is that the same thing as 4 over 1? Or let me ask you this. Would you rather have a 1/4 of a donut? Or would you rather have 4 donuts? Okay, whenever you have the 1 on top, you have to write it. Let me repeat that. When the 1 is on top, you must write it. It turns it into a fraction. When the 1 is on bottom, you don't have to write it. That's just a whole number. Okay, it's not a fraction. Okay, so when the number is on top, do you have to write it or don't you have to write it? Okay, do you have to or not? Yes, we always have to write it. In fact, I'll write that as a little note. When the 1 is on top, you must write it. Exclamation point. That's a rule. Okay, awesome. So let's do number 3 really quick. Okay, so let's expand it again. So we have 3 cubed on top. So this means 3 times 3. 3 multiplying by itself 2 times. And on bottom we have 3 to the 4th. So 3 times 3 times 3 times 3. Okay, well let's cancel. Here we go. So I see a 3 right there. See a 3 right there. How many 3s do I have left on bottom? 1, 2. So 3 squared on bottom. What is the creepy invisible number left on top? It's 1. Do we have to write it when it's on top? Yes, we absolutely do. So our answer is 1 over 3 squared. 1 over 3 squared. Beautiful. Okay, let's look at number 4. Number 4 looks a little different, but oh my gosh, let me show you how easy this is. First of all, we don't really see any exponents on here, so you're going to think, why am I doing exponent rules? So there's an invisible exponent right here of 1 and 1. Okay, that's just for your knowledge. Okay, but what happens? What's that fun rule whenever something's the same on top and bottom? Okay, it just cancels out. But what is our answer here? Okay, is it 0? This did not turn into a 0, guys. Okay, that's like saying you had, I don't know why I always use donuts. Maybe it's because I love donuts. You have a donut, right? You have something here, and then you made it disappear. That goes against the laws of science, right? You can't make something disappear. So you have to think of the invisible creepy numbers that are there. 1 over 1. Okay, that just equals 1. Our answer is just 1. Okay, because when there's a 1 on bottom, remember, you don't have to write it. You can just write the 1 on top. I know, kind of crazy. Okay, 1's really creepy. 1's that creepy number that's always there. Okay, let's look at 5. This one's a little different because we have some variables, we have some k's, but we also have a number, a coefficient, which is 2, right? So we have our 2, but do you guys see anything that can cancel? Anything that's the same on top and bottom? So I see a k over a k, right? What is left? What's left on top? Just that 2. Great. What's left on bottom? The invisible creepy number. guys are always going to think of 1 as the invisible, creepy number. Okay, my 1's on bottom. Do I have to write it or do I not have to write it? It's on bottom. You do not have to write it. So this just becomes 2. Great job. So good. Okay. Awesome. Let's go to, actually, let's skip 6 and 7. We're going to skip those two. And let's talk about number 8. So I'm just realizing now on your notes, I actually didn't provide a space to define the 0 rule. So we're actually going to write that in. So remember, you guys, you're filling out your notes. So down here in the corner, we're going to define our 0 rule. Okay, I'll even zoom out so you can kind of see it a little better. Okay, so down here in the corner, I'm going to define 0 rule. Okay, and this is where I actually want you to write this sentence. Anything, even underline anything, to the power of 0 is 1. Yep, anything to the power of 0 is 1. Okay, so right now, I want you guys to look at numbers 8, 9, and 10, and where can we replace something to the power of 0, and where can we put a 1 in it? So let's look at 8. Where can I just replace the entire thing to put a 1? Yep, right there. Okay, this 2 to the power of 0 is 1. Okay, well now let's solve it. What is 2 times 1? It's just 2. See how easy that is? Okay, anything to the power of 0. Let's go back to our definition. It can be x to the 0, that's going to equal 1. It can be 10 to the 0, that also equals 1. It can be 1,346,253. I don't know why I said dollars. Maybe it's because I want that much money. To the power of 0 equals, yep, 1. It doesn't matter. Anything to the power of 0 equals 1. Anything. Okay, so we know on number 8 that equals 2. Okay, what about 9 and 10? Where can we replace the something to the power of 0 and get it to equal 1? On 9, I see 3 to the power of 0. Great job. That's just 1. Okay, well, what is 3 cubed times 1? It's 3 cubed, because I want you to write this. Anything times 1 is itself. Okay, so let's look back at 8. 2 times 1, it was 2. 3 cubed times 1, it was 3. Anything, whoops, I realize you can't really see that. Anything times 1 is itself. Okay, again, 2 times 1, 2. 3 cubed times 1, 3 cubed. Nice job. So let's go to 10. Last one. Where can I'll zoom in a little bit. Where can I replace something to the power of 0 with a 1? Nice job. I see 3 to the power of 0. So I'm going to replace that with a 1. Okay. Ooh, but now you're going to say, well, wait. I can't just say it's 3 cubed because I also have this 3 squared. This is where we need to bring in our product rule. Yay! Beautiful. Okay, so we have a 1. Let's write this in expanded form. 1 times, how many 3's do we have in this second term? 3 cubed, 3 of them. Okay, times, how many 3's do we have in this third term? Squared, so 2 of them. Okay, the 1 doesn't change those. It's just going to be whatever. So let's find out how many 3's. What is 3 to the power of? 1, in fact, I'll use a different color. Okay, 3 is going to be to the power of what? 1, 2, 3, 4, 5. So we have 3 to the power of 5. Bring down the 1. 1 times anything is just itself. So 1 times 3 to the 5th is 3 to the 5th. Beautiful, you guys. Okay, your notes should look like mine. Okay, all filled out, all pretty. If you have to rewatch this, if you are learning at home right now, please feel free to rewatch it. Maybe even try those 6 and 7 that we didn't do. But now you will have your assignment to do on Canvas. Okay, you guys are awesome.